a seat. The seat available. All right. Good morning, everybody. We're on time, and I propose to start the second day. I hope yesterday you enjoyed your get-together. So the wine was not so bad for me. It was a Bordeaux wine, or close to. So thank you very much to be there also today. So we'll start, of course, very interesting presentation. The first one will be talking about human factor in operation and maintenance. This is a key element for all of us. We are all human, all subjective people, so we need to all the time to better understand and to try to push away of the subjective part for everybody. So I will call first Bettina Schleid, the University of Applied Science of Heidelberg. So would you please join us? Thank you very much, and have a nice day.
Thank you, Jean-Marc. I thought it would be good to start with a little video. And I would like to ask you to just follow this video and to see if you can see any, we call it film or video mistakes, some changes that might be in this video. And I will ask you afterwards how many changes you saw.
Watch this next sequence carefully. At the end, I'll ask you a question about what you've seen.
Hi, I'm Magic Singh, and today we're in Portobello Road, and I'm going to show you guys a classic in Magic, using matches. And today to help me out is Mark. Mark, tell you what, place your hand up for me nice and flat. Now, I promise this won't hurt, all right? So here's the idea. Let's just light this up, and if you close onto that nice and tight, here we go. Watch this.
Keep watching.
I don't know if you felt that or not. I'll tell you what, have a look inside. Open it up. See how the match is actually returned into the book, and it's still burnt. Okay, you're not impressed. All right, it was my first trick ever. But here's the idea. Just place that back in your hand, close it tight, and turn it face down again if you can. Now we're going to use one more thing, and we're going to use a magician's best friend, playing cards. Now the idea is really simple. You're going to choose one. So take any one you like. Perfect. Have a look for yourself. And do me a favor, show the camera as well if you can. Brilliant. And you know what? Place it back face up on the deck. Now, it doesn't matter if I see what the card is, because we're going to do something completely different. Just watch this. Here we go. I'll do it slowly. Watch the king. I don't know if you felt that or not. Tell you what, have a look inside. Open it up. Oh. Check it out.
It's the King of Diamonds. It's my card.
Brilliant. Thank you very much.
Very much.
Did you watch the trick closely? This is a famous illusion called inattention blindness. This illusion is not about the magic. While watching the routine, you may or may not have noticed the changes taking place. The question is, how many changes did you see? Was there 1, were there 3, or were there 5?
Okay, this is a question where I'm coming in. How many changes did you see? Who saw 1? Hands up. 1, 2. Who saw 3? Oh, wow, not so bad. Okay. 5? Okay, so we put it up. It's all about human factors for sure, you know.
The answer is there were 3 changes.
Very good.
The first change was the red hanky to a green one. The second was his shirt swapping to a t-shirt. The last was his assistant becoming a completely different person. How many did you see? So why is it that you didn't see these big changes? And the reason is that the brain receives so much information on its eyes that you can't see everything simultaneously. So instead it picks and chooses according to what it thinks is important. If you change something that it doesn't think is important, you just literally don't see it.
Okay, that's about human factors. And that is the reason why I wanted to show you this little video to have your attention for sure. So human factors is all about people, like you mentioned, doing their business in the product life cycle of a helicopter. From the design to maintenance of the helicopter, flying the helicopter for sure, recycling the helicopter at the end of the day, hopefully not too early. So everywhere where people are in is all about human factors. And as you all know, we are limited. And this is one of the examples why I showed you this, and I will come back to this later. So this is a little part about me. I think you can read this in the presentation that EASA is distributing, so I don't go into this too deep. So I'm a psychologist from my background and also a commercial helicopter pilot, quality manager, and so yeah, a lot of relations to helicopter and helicopter flying. And yeah, that's me. So what is the human factor? Just again, a little bit of a definition, but I think we all know about that a lot. How is it related to safety? I will not give too many statistics about safety and how many percentage of accidents are related to human factors, but you know, just a little bit. What is personal development? And this is the main topic I want to talk about in this context, to say, okay, is CRM as a training, or is human performance and limitation as a training topic enough to do and to strengthen human factors, or might there be other possibilities or tools to do more for people in our industry? Is it us? Okay. So, and there are tools for sure for personal development, not into deep, because it's just 20 minutes, and I try to be fast. I have also a little bit of an accident analysis, which might be an example for where I think human factors and probably the basic training were a problem, and the competencies that the person, the pilot, would have needed in the situation which led to the accident haven't been there. There was a mismatch probably, which I will talk about a bit later, and short conclusions. So what is human factors? You all know that. We talk about thinking, feeling, behaving if we work in the product life cycle of the helicopter, flying it, maintaining it, as I already mentioned, which is a lot. We talk a lot about technology in this context, and more technology, Industry 4.0 in the automotive area, but also in the area of helicopter flying or flying in aviation in general. And we talk about the interaction of the human being in all contexts and everywhere in a complex social technical system. So we talk about human beings in context and relation with technology, growing technology. So here you can see a classic approach. We talk about maintenance, for example, which is these guys are working on I think it's a Bell 206 rotor head, and this is Robinson. Of course, not like Eurocopter or Airbus helicopters. They're a real big helicopter, but also a piloting task. And people doing these tasks and behaving are always related. You can reference to the Shell model as well in this context around the organization. They are related to the organization they are working in. Normally, you're somehow related to some kind of organization, processes that you have, or operation manuals that you have. Also surrounded by human beings, other people that you are working with, ATC, colleagues, crew, or colleagues that are working on the same topic perhaps with you. And for sure, I already mentioned this, technique. So this is a small, don't worry, I will not go into this too deep. This is framework which I developed that can show you how complex it is if we talk about human factors. I will talk about later more or less about competencies, which is just one part of human factors or psychology behind everything that we are doing. But you can see this is an input process output model. We have some kind of stimuli, tasks that we have to do, that we are asked to do, piloting a helicopter, for example. Then we have all this, what is between the ears, the human brain, the head, whatever, the psychology behind. And here at the end, normally the output should be some kind of behavior that you're doing. You're somehow flying, you're somehow working on the helicopter, maintaining it, for example. And this is all somehow related to, for example, here on your personal side, by knowledge, attitude, goals, memory, concentration, attention, like we had. A lot of things that are coming in from you personally, from the person working in this context, but also from, for example, the technology you are using, the usability of the system, the human system or technique interface. We talked about this yesterday several times. The grade of automation, a lot of things going on. The more you have an automated system, the less perhaps the more you lose your personal piloting, manual piloting knowledge and competencies. Processes are already mentioned. And then for sure, if you fly, for example, you have environment. If you are maintaining, you have environment as well, perhaps very hot, very cold in the wintertime, cold hangars with not very much heating, and that kind of stuff. So it's a pretty complex thing. So, and this is something I typically show when I talk about Industry 4.0, but it's also valid, I think, for the helicopter and aviation business. So we have on the one side, what I already mentioned, the human potential, which is this red line you can see here, which is limited like always. There are some possibilities to use a system to enhance the limitations, the human limitations a bit, but mainly we are limited like ever. We can't expand our memory, we can't expand our attention, we will always stick to who and how we are. So we are limited as human beings. And on the other side, we have the technical development which comes in, which is the yellow one, you can see here, and it's growing and growing. And from my impression, you can correct me or we can discuss perhaps later on, there's a huge gap between technology. Technology drives the business everywhere, and the human being and its capabilities and possibilities. And this is getting more and more over the time. And this makes life for psychologists and for pilots, for example, not easier in this context. Here you can see how people feel. This is not from a helicopter business, but from an automotive study that we conducted. You can see it's all about feeling somehow overwhelmed, surrounded by a very complex system. A lot of partners you have to interact with, for example, in the product development area. The conditions are unclear, processes are somehow very complex. The product itself is complex, and there are so a lot of things influencing people in these times at the workplace. And this might be perhaps a good reason to say, okay, we have to focus more on the human being and not that much on technology that we used to. So to think about perhaps doing more structured and systematic around human being and human people development, Personalentwicklung in German, starting from the area of hiring people, also basic training of people, not only talking about how to fly a helicopter, for example, which is, I think, on the next, no, not yet, I will show you later on. So trying to build up different competencies and other competencies than at the moment. This is a very simple personal development, people development approach, which says nothing else than if you have a person which is in special working conditions, you can describe these conditions, working virtually, working intercultural, that kind of stuff, has the fitting competencies, like in this case, and these conditions this person is working in fit to the competencies the person has. you have at the end competent behavior. Just talking about competencies at the moment. No? I know, all know it's more than this, but it's a good starting point for personal development. In this case here, that's why I put it in red. You see working conditions and competencies don't fit together. And there you can see it incompetent or less competent behavior, which you can find. Pretty simple, but I think it's a very good point. And you can see in the accident analysis that I have later on that we are probably here in this area with a pilot flying. So, and this is the competency orientation of people development or personal development, which I talked about. Above the water level, you can see professional competencies and methodological competencies are things that we are already very good in. You know, we explain people, students, how to fly the helicopter, and we let them do it. They know all about emergency procedures, that kind of stuff. But, and the but is this what is beneath the water level. We talk about social competencies, personal competencies, perhaps sometimes, but I think not very often. At least if I see my own education, my training that I had, also in the engineering area, but also in the helicopter flying area, I can say these competencies beneath the water level weren't a real big topic. So it was something I had to learn from experience, learn from other areas, but it was not part, structured or systemic part of my training, of my basic training. So what is personal development? Just a very small and slight definition. We talk about systematic support of people in their business, at their workplace, in an organization, for example, by what we already do. We have it legally put together with seminars like CRM. We talk about, on the other side, for example, about tools like coaching or mentoring, giving people, other persons to the side to talk with them about different topics. As an example for mentoring. Also peer supervision and consultation might be a good tool which we could use in organizations to discuss problems between colleagues, for example. And on the other side, also something like self-reflection and resource management for the individual, for everybody working at his workplace. And for sure, the goal of people development and personal development is to strengthen competencies in this area which I mentioned, social and personal competencies. And so to foster and to strengthen safety on the one side and also health, behavior on the other side, and making people happy at their workplace. And so you can see, if we come back to this framework, you can see this. You have a lot of resources also in these areas that we talked about, if you remember what I showed at the beginning. So we have all our social surrounding. For example, if we talk about peer supervision or peer consultation, we have the technology which we can use at our workplace. We have ourselves, me, our personal resources, and also the organization. And the organization, for example, comes in if we talk about personal development approaches, structured way of people development. So here's the case study. Okay, I try to be fast. It was in June 2012. It's all based on a report that is published by the German Accident Office, BFU. It was a pilot with 3 persons on board, an R44 flight path from Augsburg to Salzburg, for some people who perhaps know a bit over Munich. It was a 1 hour's flight, you can say. Everything went fine. Weather was very good. Most of the way to Salzburg, but in this area here of Salzburg, there were some clouds. Weather was becoming somehow ugly, so everything went not so bad until the area of Traunstein, which was about an hour flight approximately. Then the pilot decided to fly 2 minutes in low altitude along the highway A8, which is something like a bad weather route, I would say, because he somehow couldn't fly high enough and stick to the altitude that he had over the rest of the flight. And yeah, at approximately, well, you can say 10 minutes later, he flew in deep clouds in rising terrain into forest, and all 4 people lost their life. So these are what happened. I think it was about 80 knots. He was flying into this terrain and into the woods and forest. This is the flight path. I think that's okay. What is interesting at the moment is there was one person on board that took a video, and the video could be recovered afterwards. Also the last minutes of the flight. And there you can see he was, this was the A8, as I mentioned, was bad weather route. Then he somehow decided to go to the south again, but here he was flying to the east. Here you could see, it's in German, here was a point where the pilot lost his visibility. So he flew just into fog or clouds, seeing nothing outside anymore, beside gray or whatever. This was about 59. So you can see here was the accident. So he flew, you can say, about 1 minute with 80 knots just in clouds. And that's what they show here, hanging and overlaying clouds. And he had about more than 1 minute, no visual outside references anymore, and flew into clouds. And the question is, why, for sure? We will not be able to answer them anymore, these questions, sorry. But I think we can try to learn something out of this accident. There are a lot of questions. Communication is not that important at the moment for us, but these questions you can see. The question is why he didn't turn around, didn't do a safety landing, for example. Why didn't he continue to fly to the east, but went to the south? Perhaps he probably he just lost orientation. Why didn't he stick to his minimum safe altitude? We don't know that. Perhaps some background information, these contributing factors. The pilot was a commercial helicopter pilot, but low flight experience. He knew this flight path, but he was first-time PIC on the R-44 with 4 friends on board, which was probably, they were all excited, and he wanted to show how good it is and how cool it is to fly, for sure. And he had, for sure, high workload doing the navigation. He used just paper-based navigation, so a card, map. He had to do the communication with the tower, and he did that. Sometimes you don't understand it, but it couldn't be reconstructed. And he had to handle the helicopter, and he was pretty new in this R-44, so yeah, this might have been a problem. He probably had no plan B and was somehow completely lost in the situation. So in this where, for my personal impression, personal development comes in. I know at least from Germany, how the standard of the commercial helicopter pilot training is. And that's why I can say that. Otherwise, I would be not brave enough to say that. But for me, in this case, it was a real massive mismatch of the competencies the pilot would have needed. Well, you remember the model? Conditions and competencies that need to fit together. The competencies he would have needed compared to the competencies he learned in his basic training as a commercial pilot, which is very much related to the fact that we in Germany are not allowed to fly, to do safety landings as a part of the training normally. So you have, as a flight school, typically some area of safety landing where you can do, you can train that, but it's a very well-prepared area, and if you have flown to this area for the second time, you know as a pilot what to do. So you're not trained, like for example in Switzerland, to say, okay, we fly over country, and now we just simulate, to say, okay, let's go down, and we have an accident, or we have a problem, or we just want to do a safety landing because one of our passengers is very ill and making problems or causing problems. So this kind of decision making we don't learn in the commercial, mainly in the commercial helicopter training in Germany. And so for sure, how should he know, this pilot, how to behave and how to do this safety landing? On the other side, we learn if you do a safety landing, it's a huge mess of communication you have to do afterwards. You have to explain to the authorities, to whomever, why you did the safety landing and that kind of stuff. Okay, so this is a real problem. So this is, explains this mismatch again. And so what you typically do is learning by doing as a pilot, and which is probably the contra part and the other area of structured personal development. Conclusions. So we can't change the circumstances. So what I told you about digital work and how digitalization and technology comes in, but at least we can try to make something more around people, and we can think about other things than just CRM trainings, but also to think beyond the existing training approaches and to think more about getting social and or strengthening social and personal competencies. So I guess that's my sources, and thank you very much for your attention.
Thank you very much, Bettina. It was really a case, and it was really a pity what we heard here. But this is alive, and we all know this kind of situation. We have to improve, and we have to work on it all the time, because all the time we have to repeat that to the people, and all the time it happens again. I don't know really what could be the solution, but we will talk later on about that. Now, we will talk with our two other colleagues, flight test people from Airbus Helicopters, Olivier Wenche and Carl Oke, to talk about performance class 2 enhanced. Performance class 1, performance class 2, performance class 2 enhanced. It will be very good to have some idea about the performance class 2 enhanced. Thank you very much. Please.
Where is the button? Ladies and gentlemen, bonjour. With Carl, we have decided to share with you some information regarding the concept of PC2 DLE, which means Defined Limited Exposure. Airbus has decided to study this concept mainly for offshore operation environment. To cope the case of engine failure, performance should be limited by PC1, with theoretically no risk, but a payload reduction, or through PC2 and PC2 limited exposure, which increase the payload, but with an accepted risk. Then, since 2010, it's possible to operate through the PC2 enhanced, which theoretically should improve safety and increase the weight. But generally, with PC1 or PC2 enhanced, to achieve good performance, we need to have a high TDP associated with the vertical dynamic takeoff. Takeoff decision point, sorry. Thank you. PC2 DLE concept is based first on hazard identification. The risk during all-day operations, that means twin-engine operation, are loss of references and also the payload reduction effect. For the same amount of passenger, you are more sortie to do, so more risk. In case of engine failure, the risks are the decage, the strike with the sea, but also the loss of references. And all this risk will increase with moving deck, low experienced crew, low visibility or turbulence, or during night operations. The DLE concept is based with the objective to improve the global safety, and not only the case of engine failure. For this, we have proposed a procedure with hazard mitigation. For this, takeoff and landing procedure need to be simple. They need to be short, because you will see that with the dispersion and the time, there is a time integration and there is a drift. And the drift could be unsafe. It's why it's necessary to have short procedures. Then we need to have procedures which are robust to the normal paragliding dispersion. We consider it's better to have the same kind of procedure in twin engine or in case of OEI. And we think it's good to have a performance calculation taking into account the engine failure. Regarding the procedure, the PC2 DLE is found on a low rotation point. Why? First, to avoid the loss of references. Secondly, in case of engine failure, to be able to do the rejected takeoff. We consider that takeoff decision point needs to be the rotation point. Why? Because we want to minimize the number of actions. At rotation point, we go. And we consider also it's a way to simplify, to limit the crew misunderstanding in this kind of situation. Regarding the helicopter position, we consider that it's better to put the rotor tip tangent to the deck neck. First, because this is a way to have the largest deck edge margin in twin engine, but also in case of engine failure. And with DLE, we always assure positive deck edge margin. Secondly, because it's a way to reduce the duration of the sequences. And remember, dispersion with time is possibly unsafe trajectory. So if we reduce the time duration, the duration of the sequences, we will limit that effect. And secondly, because this is the best way to have the greatest margin regarding the rear obstacles. The performance. For this, we have done a lot of flight tests like we do when we do PC1 performances. We have used certified simulation tools, and we have used also certification criteria. All calculations are done for the worst case. That means total and sudden engine failure, like for KT. No engine power check, and with the factored wind. We stop the calculation for the exposure time when aircraft is able to fly. That means, at the end, it's a very, very conservative methodology. Thanks to this, we are able to determine a maximum takeoff weight. This weight is a function of altitude, temperature, wind, the available drop-down, and the time exposure that you will select. All these data are presently available for DLE through flight manual as KT supplement with precise description, through an iPhone application. The pink arrow is the income. The outcome in this case will be the weight for an exposure time of 1 second. And through the last iPad application, which is already available for the H175. If we make a time scale regarding the possible OE event, if for takeoff, engine failure occurs at this point, it will be a normal landing. If engine failure occurs later on, up to takeoff decision point, it will be a safe force landing. The definition is that one. An illustration could be that one. Thank you for the help. You know better than me. For me, this is the best definition for safe-force landing. We accept to damage aircraft. Now, if the engine failure occurs at takeoff decision point and up to defined point after takeoff, aircraft is exposed to ditching risk or deck edge risk. This is the notion of exposure time. Thanks to application, through this exposure assessment, we are able to determine the deck edge exposure, and we consider we have to keep this risk to lower than 1/billion, because I can guarantee you it's a catastrophic risk. Regarding the ditching exposure, the risk has to be managed according with safety management system, regarding the environment, etc., etc. For your information, presently, Total worldwide accept a maximum of 3 second exposure time. That means for most of the case, maximum takeoff weight. If no engine failure occurs after defined point after takeoff, aircraft is able to do flyaway And now I will let the control to Carl.
All right, thank you, Olivier. So I'm going to talk a little bit about the PC2 DLE application on the H145 helicopter. The H145 is not traditionally an offshore helicopter, but we've seen increased interest in flying the aircraft offshore, especially in the renewable energies market. And for that reason, people or customers came to us and said, we want to have an offshore procedure. And so we decided to build one. We did a lot of flight testing, and the first thing I will show you is just a short clip from what we did during flight testing. What you will see in this little video is a continued takeoff after an engine failure at 20 feet, just right at the TDP, the point where you basically are at 20 feet, going up vertically and want to start flying, and at that point an engine failure occurs. And for flight testing, we developed a method where we don't have to go on an actual heli deck and find out if we have a deck strike or not, because we don't want to find that out in flight testing. So we developed a method where we can do the testing in free air. And what you will see in the video is the helicopter. You will see the helicopter move upwards and then basically do the emergency takeoff. You will also see on the right panel there, on the very left, this portion here, you will see the power indication and the rotor speed, and you will see the radar altitude in digital value. That's basically what the pilot's going to use. What we as flight test engineers use during that test is the little thing on the left, the little square on the left, where we can actually see in real time where the aircraft is in relation to the virtual helideck, which we place in 170 feet in free air right now. And we see basically the little pink line is the helideck, the little D-shaped form is the deck edge clearance that we like to have. So let me try and start a little video. Okay, so what you see here is basically the helicopter is in a hover, and the video is going extremely slowly. Let me see. Let me see. It's still extremely slowly. What we see basically in slow motion here is a pilot pulling up to maximum takeoff power. And we tried this yesterday and it did work. Okay, so you see him pulling up to maximum takeoff power now. He's at about 20 feet above the deck. At this point, he should... Okay. So I'm going to skip the video, but basically what you would see is, or what you see now is basically he just went into OEI here. You see DNR has drooped. He's recovering. And what we can also see on the left is that he's basically cleared the deck edge, and that he will have a deck, he will basically fly away with a loss of height of about 55 feet below the deck. Sorry about the video. It did, as I said, it did work yesterday, but let me see. And now it's working just fine. Okay. No, we'll just continue with the presentation. And okay. So the main thing about the 145 is we use the same procedure for PC1 and PC2 DLE procedure. The normal procedure, as we just explained, is you go tangent to the helideck, you climb vertically to 20 feet, and you just rotate with 10 degrees nose down to fly out. Very natural, very basic. If the engine fails before the TDP, well, just basically land back onto the deck. You're only at 20 feet. Maybe you'll balloon up to about 30 or 35 feet. You'll just do a landing, and with the 145, there's always a safe forced landing possible. There's never an exposure time before the TDP. When you have an engine failure after the TDP, well, you can just rotate to 5 degrees a little bit more, nose down, and you continue to take off. Again, we always ensure deck edge clearance, and depending on the deck height, you either have to ditch, which means you'll have an exposure time, or if the deck is high enough on the H145, you just transition to a climb and fly away. The takeoff weight for the H145 is calculated to the P2 DLE flight manual. There will be an app soon, but it'll take a little bit of time to develop that. As I said, whatever the takeoff weight, never a deck edge risk, and even only if you have a heli deck that's very low above the water will you ever have an exposure time. Otherwise, there's no exposure. Always a safe procedure. Landing, again here, PC1 and PC2 DLE have the same procedure. You arrive at about 100 feet above the heli deck at 30 knots, slightly offset to the platform. You descend to 50 feet above the deck. At that point, you decide whether you want to continue with the landing or go around. And then you just basically approach the deck, and at 30 feet, so you're about, quite steep, and you basically land the aircraft to the center of the deck. If you got a failure before the landing decision point, well, you just go around. Since you're at 30 knots, your height loss is minimal. You never descend below the deck height, or you basically continued with the landing, because you can land single engine, typically in the performance we have with the H145. So you just do as you do for the normal procedure, except that you only have one engine working, and you'll just land it safely at max takeoff weight. So we're never, on the H145, we basically never have an exposure risk on the landing. So conclusions on the H145. We standardized the PC2 procedures with the PC1 procedures. The procedures are simple and intuitive, which is also, thinking about the last presentation, a very important aspect, because the last thing people want to do when they have an engine failure, they get scared a little bit usually, is to think much. It has to work. You don't have too much time to think. So engine failures have to be easy to handle, nothing complex, no 5 different things to do at the same time. And also we have the same procedures for the H175, soon to be for the H160 as well, so that we have the same set of procedures for all the aircraft. So people going from one aircraft to the other don't have to learn new procedures. One final remark just on engine failures, because engine failures are not the only risk for offshore operations, but it tends to be the thing that people talk about. Why? Because they're so predictable and trainable, so everyone can train for engine failures and do all that. Still, we have to see there's lots of other things going on. Having an intuitive cockpit, having systems that reduce the workload, like an autopilot that helps you to go vertically. Simple procedures, a good field of view, situational awareness contribute at least as much to safety as having lots and lots of single engine performance, which will get you through that 3 seconds of exposure time. And for some final remarks, I'll give it back to Olivier.
Thank you, Carl. So, time to do the synthesis regarding the PC2 DLE concept. First, PC2 DLE is only a toolbox to reduce the global risk, which is our objective, with defined, simple, and robust procedures, with smart application to have optimized weight and to have a notion of risk, which is consistent with operator SMS. Thanks to PC2 DLE, we bring standardization worldwide because we have the same procedure for PC1 or PC2, which is very important for safety. And PC2 DLE is compliant with EASA OPS regulation. But what are the evolution for tomorrow? Remember, performance are limited by the drop-down or other things. For low drop-down available, performance could be limited, or you can increase your risk. To avoid to increase the risk, we can imagine to increase the TDP height, but it's in opposition of the previous discourse. Except if tomorrow we use the advantage of holding mode with autopilot module, okay? And we use also a display which helps the twin engine and the OEI vertical climb. We are presently working on that side for new helicopters. Other type of operation, the DLE concept is a means to objectivize and reduce the catastrophic risk. We consider that this benefit could transfer to other operations. For this, we let you to invent, and we are here to help you. Thank you very much.
Thank you very much, Olivier and Carl. Sorry. Now I suppose you have better understood, but we have plenty of pilots in the room, so probably we will have some questions at the end of the session. We just have a very good conclusion saying it could be applied to other type of operation, because at the beginning you start with the offshore, but everybody was thinking, what about the EMS operation on elevated helipad? So maybe you have to answer the question. So now we will change again. We talk about EBT. Yesterday we already had a presentation. So now it is the EASA colleagues who will present you something regarding the EBT. And I am calling now, yes, Eric, and Francisco, Arena, Alvino. So all together, they will start to talk about EBT, EASA point of view. Thank you.
Good morning, everybody. Let me introduce you to competency and evidence-based training. Of course, you've had yesterday's presentation from David Apad. He's in the room today as well. This one will have two sides. First, re-explaining the concept a bit, and the second part of the presentation will be about the regulatory environment. So first, who is affected by EBT? Well, obviously, it's going to be people flying IFR, people flying offshore, HEMS could be also interested. Basically, everyone who flies multi-crew and has access to simulators will be able to benefit. Authorities, ATOs, AOC holders may be part of the people who will be impacted. So what happens if you're not in this list and roughly not interested in EBT? Can you sleep for the rest of the presentation? Well, not quite. What you need to know, what's important for you, is that EBT is not mandatory. The prescriptive training requirements will remain. So if you cannot do EBT because you don't have access to SIMS, for example, or if you just don't want to because you like the prescriptive training requirements, then you just don't do EBT and you carry on with business as usual. Also, if you are not part of the list of people who will be interested in EBT, please do listen to this slide, because this is the one for you. It happens that we're introducing EBT through the rulemaking task 0599, and this rulemaking task also includes the review of ROFC, therefore the review of the prescriptive training requirements. This part of the task is the one that will make it first through the regulations as well. The NPA is due to be published by the first quarter of this year. So please check out the NPA section of the EASA website. Do look into this NPA, and please do send your comments if you have any. The main features, the main changes that we will bring to the ROFC will be, first of all, the multi-pilot operations of single-pilot certified helicopters. We'll actually not only change ROFC, we will change part aircrew as well. Basically, we'll change the privilege of the ATPL. We will change the requirements for ATPL theory. And whenever you fly multi-pilot, whether voluntarily or not, in CAT, SPO, or NCC, you will be required to get multi-crew cooperation training. We will also change recurrent checking requirements. We'll streamline operations on several helicopter types. Also introducing a few minor changes about CRM assessment, CRM theoretical knowledge, aerodrome competency, especially the VFR aerodrome competency in helicopters. We'll also change qualifications to fly in either pilot seat, and a few other minor things. So please take a look at this NPA. Now, let's focus on EBT again, and for this, I would like to give the floor to Francisco Arenas.
Hello, thank you very much. I am not a rotorcraft pilot. I'm a fixed plane pilot, but I will be trying to explain you the whole concept of EBT, because aeroplanes is a little bit more advanced than helicopters in this. However, my brother is a rotorcraft pilot, so I am familiar with this windmill stuff. Okay. So, summary of yesterday. David is here, but basically I want to summarize in 4 bullets what he explained yesterday. The EBT is trying to address the operational risk. Yeah, sometimes the regulation or the way we check and train has gone a little bit offset from the original idea of training the operational risk. Probably because there's a lot of changes since the 50s until today, and maybe we declutter a little bit the regulation. Yeah, so EBT is trying to bring back the operational risk into training, and for that purpose, we are doing a data report for helicopters. I have a little note that, of course, not all operational risk can be mitigated through training. There's equipment and there's other mitigating measures that also has to be into account. The other point that I want to mention about EBT is that is pilot resilience. I think David already explained yesterday with the black swan what we mean. If there's any more questions about pilot resilience and train for the unexpected, then please raise a question and I will be able to explain further on the questions. Also, evidence-based training means evidence. And so what we mean with evidence? Evidence-based training have 3 levels of data. The first one is the regulator through a data report where we're going to revise with the helicopter people around 500 accidents around the world in order to find the operational risk or acknowledge those operational risks that I mentioned before. Then the second level, by the way, the regulator through the data report will publish the baseline program, the EBT baseline program. The second level of data or of evidences are the operator evidences. So the operator will take the EBT system, they will add some management system and some other internal data, and it will tweak or it will adapt the EBT baseline program to their operational risk. So they will tailor-made a training program. And the third one, and the third level, is the instructor level or the crew level. Yeah. Here, what we're trying to do is that the instructor will evaluate the pilot on the first day, and then tailor-made on the second day slightly, because of course there's already been a tailor-made by the operator. It will slightly adjust the operator's training program to that particular crew or that particular pilot on the second day. Finally, the EBT has another very important leg, which is the instructor standardization, instructor concordance, instructor training, call it whatever you like. This is very important that the instructor deliver correctly the training program and also assessed in the same way the pilots. All instructors should assess in the same way the pilots. Otherwise, the data that you bring into the system will be corrupted in a way. So it's very important that instructor standardization. This, I think, is a short summary of what it was discussed yesterday. Now, this is the idea, and this is real data from an operator, fixed wing. In legacy training, they were doing a lot of tests. When they moved to ATQP, this is one of the competency-based training programs available in aeroplanes. They could bring more training into the program. Now that they moved to mixed EBT, well, in fact, they are moving now on the 1st of January 2018. They already developed the program, and this looks, and this is real data again, yeah? This is going to be more than half of training. And finally, when they implement EBT in 2019, 2020, they expect to see this picture in which you do a lot of training and you do a lot of line-oriented evaluation, which is going back to the real life, yeah, real stuff.
What do you mean by test?
Test means checking, yeah, the old checking of Appendix 9, maneuver-based, tick the box in order to comply with the regulation, yeah, with the legal stuff. Okay, so this is the idea of evidence-based training. Now, I want to explain a little bit more about now more into the process of what we think in EASA. So EBT has a lot of interactions, and I'm going to try to summarize everything. Yeah. So the first idea that we want to bring is on phase 1, we want to have a single philosophy of training through EBT. Yeah. So we are trying to touch the operator recurrent training and checking. I'm talking about ROFC 230 and also low visibility. So the operator has a single philosophy of training in recurrent training. Yeah. The next phase will be to move into the OCC, into the operator conversion course. Of course, operator conversion course means also type rating, because you can do type rating and OCC at the same time. So that, by the way, these are the interactions that we're going to have in each phase. So in recurrent training, we have interaction with all-weather operations 0379. The MPA will be published on the first quarter next year. And then in the type rating, we're going to have interaction, and we are coordinating with the CSF STD rulemaking task. So when we completed this item, we will have, and let me see, a single philosophy of training. Be reminded that TRE, TRI courses, so subpart, Juliet, and Kilo, are linked to the type rating. So we may have interactions there as well. But the idea is to complete a single philosophy of training for the operator through EBT on the second phase of EBT. I will explain later on the phases. Finally, we want to add new products into the EBT. Currently in the ICAO, there's only 4 airplanes, and we want to bring the helicopters. And we are creating with some of these people that are here in the room the way to introduce helicopters into EBT, so that we have a single philosophy of training across the industry. So it will be enhancement through data exchange and possible data exchange between the whole industry. Yeah. Okay, I move on and pass the...
Thank you, Francisco. So let's come back to helicopters. And I believe that with a long list of mandatory maneuvers that we have to do every 6 months, there's even more improvement to get from evidence-based training than they had in fixed wing. Also, as we didn't have the ATQP option in our helicopter rules, we're going to leapfrog this step and go straight to EBT. In order to go to EBT, though, this being evidence-based, we need data. So we need to do our own helicopter data report. And this we need to base on pilot competencies. What's the easiest for us to do then is to use the aeroplane competencies, and those that are described in the ICAO document for aeroplane EBT, the document 9995. It happens that we have 2 differences. We add knowledge, the way that is already done by the EASA aeroplane EBT concept, but we're also looking into the monitoring competency for helicopters. Does that mean you don't need to have monitoring competency in aeroplanes today? Of course you do. But this competency is split into all the other competencies. What we're looking into for helicopters is creating this new competency because we think it's worth it, and we think a number of issues can be trained through this monitoring competency rather than this being split into several others, not getting the complete picture. So we're doing the data report, and once again, thanks to the analysts that have been working in David Abad's team that were discussed yesterday, we're doing this data report in accordance with this list of competencies, and if at the end of the day we believe that it's better to go back to the aeroplane competencies, then it'll be all the easier. Next, we need to do training, but we need to adapt this training to all helicopter types. And in order to know what kind of training is needed, we need to do the data report in accordance with different kinds of helicopters, with different types of automation, different philosophies of operations. So we've decided into a split between generations. Actually, this is for training only. That means you can buy a brand new helicopter that is generation 1 and will be perfectly fit for purpose. You can also fly a generation 3B helicopter, and that will not make you a better pilot than someone else who's flying generation 2. It's only that the training focus will be different, and therefore we're doing our data report accordingly. And now it's time for Francisco to carry on the presentation.
Okay, now the end of the presentation is just the boring stuff, the rule-making procedure, and it's a bit more bureaucrat, let's say. So the group is composed by 32 people. There's people around the world. As I said before, the data report encompassed 500 accidents around the world, and we thought EASA is the first regulator to really implement EBT, and we invited people around the world. Yeah, this includes airplanes and helicopters as well. Okay, so the phases of document 995, basically the document 9995, ICAO, says you need to train and assess according to the EBT principles. Then you move to mixed EBT. Mixed EBT means that you still do your Appendix 9, you still do your LPC, you still do your OPC, but you embed in your training program the Appendix 2, which is the baseline program of EBT. So it's quite difficult. You still have the safety net of the LPC and OPC, but this is you are in a trial mode. Yeah, we're gonna require probably, let's see, the operators, aeroplanes operators, to stay 2 years in the mixed implementation. Okay, then you will move to EBT baseline. Again, here you will have a single philosophy of training for the operator in recurrent training. Yeah, and here in EBT baseline, you move your LPC and your OPC to a competency-based program, and you revalidate your license, you revalidate your OPC through competencies. This is the EBT baseline. We're going to publish on the first quarter 2018, the NPA. Finally, you have the enhanced EBT. This is for large operators in which your management system, and you have a large management system with a lot of data. You basically can do your own data report, and you're going to address your operational risk a bit better. And this is what is called enhanced CBT. Okay? The helicopter size of the operators, I don't think it will allow the enhanced CBT. It will be there in the regulation, but I don't know if there's going to be such a large operator that could manage the enhanced CBT. So this is the ICAO document 9995. But in EASA, we believe we need to go further because, as I said, we want a single philosophy of training in the operator, and we want a single philosophy of training in the industry. So mixed implementation is already available to aeroplanes with the helicopters, it will be available when we finish the data report. Because there we will publish the EBT baseline program, and you will be able to access to mixed EBT. Baseline EBT, I already discussed this. This is phase 2, phase 1 of rulemaking task 0599, which is the second step. And then, in order to allow a single philosophy of training in the operator, we need to do this initial EBT type rating and OCC. Yeah, this is enhancing the ICAO document 9995. So we are in new territories because ICAO already provided the concept for recurrent training and checking. And now we need to go a little bit further and provide the EBT type rating. This rulemaking task, or this phase of the rulemaking task, will start next year. Finally, we already know data report for helicopters to integrate new types, new aircrafts into EBT, so we can have a single philosophy of training in the industry. Next, and this is just an add-on, we are introducing, we are studying the introduction of virtual reality in aerodrome recency in aeroplanes, and we hope that the helicopters also joined. It's just a study carried out by NLR, the Netherlands Aerospace Center. They are exploring to train the aerodrome's recency through virtual reality. Today, the aerodrome recency is carried on either in the sim or you go as an observer to an aerodrome. They are providing a study with extensive data collection and extensive test in order to see if it will be an option to train the aerodrome recency. Like instead of being in the observer seat, you put the glass on, and let's see if we have good data and good study that we can incorporate this idea into the regulation. This is also available for, let's say, mature operators that can. It doesn't need to be in the simulator training device. However, we expect this option to be for mature operators. Yeah. The presentation will be available on the internet, and you can read what we are doing, the regulatory roadmap. And now, very concrete days. Again, phase 1, 2018, MPA, non-EBT issue plus EBT issue, concept paper of data report, team, David, and the rest of the team is here. We plan to publish on the first quarter 2018. Helicopter CBT concept paper data report, which is more or less on the workshop, yeah? Then a phase 2, in which we will publish the final data report, not just the concept paper, but the data report, in which we will make available the EBT baseline program, and that means mixed implementation is available. And finally, a phase 3, 2022, for helicopter CBT regulation baseline, yeah? And the dates ready to use are 2 years later, basically, okay? And that's it. Thank you very much.
Thank you very much, Francisco and Eric. EBT, the way we have to think now and in the future. Thank you very much. Probably we'll get some questions also. Now, we will move to the 4th speaker for this session. So, please. Now, we will have some, we say that believing in safety, we are all convinced by this. So, Miguel Van Leven Garcia from Babcock MCS. Thank you very much.
Ladies and gentlemen, if I could offer you only one tip for the future, attention would be it. As we learned this morning, attention leads to safety. Distractions lead to accidents. My challenge for you during the next 20 minutes is to test your attention. Free yourself from distractions, and let's see if this is the only screen that you can watch during 20 minutes. Okay? I will use my voice. I may raise my voice to keep your attention. I may close to you if you are not doing it right. I may ask for higher authority for your kind assistance if everything else fails. Do I have your attention? Thumbs up. Are we ready to go? Thank you. "98% of people have never flown in a helicopter, and they need not to." This phrase was said by the Prime Minister of Spain in a primetime TV show about 2 years ago. Not good marketing for helicopters. He was talking about his own accident in 2005 while taking off from a bullfighting ring. Are you in the other 2%? We are here to help you. By we, I mean Babcock International. It's a very big company. Very impressive figures. To me, the most important figure there is 1891. If this company has been around for so long, they must be doing something right. Operations all around the world. And within it, aerial critical services. I'd like to think of our people as angels. They go there flying when you need help. We are flying in many countries in Europe, Africa, Australia. And this is where I come in, Spain. I'm the safety guy for Spain. We fly over 150 aircraft at many locations. We maintain them in Alicante, Salamanca, Albacete. We do emergency medical services, search and rescue, oil and gas, firefighting, surveillance, maintenance, training, and design. The key here, of course, is highly trained professionals to manage critical assets, to deliver complex services. Going back to the topic of the presentation, how safe is flying helicopters? Well, helicopters do defy gravity. They have dangerous rotating blades, and they operate with many liters of fuel. That's an interesting combination in terms of safety. And that's why we need strong safety management systems to design them, to operate them, to maintain them. But please remember, more fatal accidents happen driving or going up and down stairs than in helicopters. What's the common element in designing, operating, maintaining them? Humans. Human error. It's an emphasizing on human. Machines don't make errors. Machines don't make decisions. So it comes all down to culture, to the way we think, to the way we decide. So consistency in training, communication, support for the right decisions is needed if what you want is to have the right safety culture. What guides culture? One definition of culture, it's a common set of values. That's the set of values of Babcock International. Very strong on safety. And of course, sometimes strive to deliver or safeguarding customer reputation can be somehow in conflict with safety. But the key is never compromise on safety. Expectations and behaviors. That's another way of defining culture. And we work a lot on that. On asking each other how to do things better, on the commitment from the company to every employee to make sure that they have the right training, the right tools, the right time. And of course, we share to learn and improve, transparency, and telling each other everything that we can do to improve. So, I told you I'll be asking questions. From 2000 to 2012, the group of operators that now form Babcock MC in España, formerly INAR Spain, had an average of 3 accidents per year. In December 2013, at this same forum, we announced our 0 accidents goal. How long do we maintain that goal? 3 years, 3 months, 3 weeks? It was only 3 weeks. On the 20th of December, we had 1 accident. But, and this is a big but, that was the last accident we had. I learned today that that is a safe forced landing. The pilot walked out of there perfectly, unhurt. I don't know whether that's a hostile environment or not, but that is an accident. That's a terrible graph. It shows all the accidents that this company suffered since the year 2000. Where you see red lines, it means lost lives. And then, we're now almost 4 years without accidents. Some people have said that that's good luck. I respect very much everything that is luck and any outside intervention, but it will be unrespectful to all the people who have worked very hard for this to happen if I allow just to think that this is only good luck. If this is only good luck, what are we doing here anyway? We were lucky to have wire cutters installed when these firefighting helicopters flew through wires. Nobody got hurt. We were lucky with this bird strike because the pilot was wearing his helmet and the visor down. Nobody got hurt. We have been many times lucky by detecting failures and errors, by monitoring vibrations or the way our pilots fly. We've been very lucky to fly helicopters that are well designed and well maintained so that they can sustain lightning strikes, and crews well trained so that they know what to do when this happens. I guess we've been lucky that that tag was placed in there because that big flashlight was forgotten inside a helicopter. But luckily, somebody else found it before it interfered with flight controls. Nobody got hurt. And we are lucky to have resources and the help of many to make decisions, hard decisions sometimes. Now, more questions. Do you see the differences? It's easy to know the difference between an ambulance, a limousine, a bus, correct? But when it comes to helicopters, unless you're working in the business, maybe you don't have it so clear. And this leads me to question number 2. This is not my company, okay? 2 helicopters there is a wire in between. So which approval did this other operator, not Babcock, use to perform this operation? AOC, SPO, HHO, maybe helicopter hoist operation. An approval that allows to use a helicopter in service for civil protection to rescue other helicopter of the same operator that crashed during fumigation works. I'm not giving you the answer. I'm just warning you. Under the scope of civil protection, there are many things done a bit weird. And we have seen people doing HEMS flight, firefighting, search and rescue under civil protection. When we do that, we give them the right training, the right approvals. And I'm not sure everybody does it. Multiple question 3. Everybody has heard today and other presentations about bow ties. That's a bow tie, yeah. Short explanation of bow tie. That's, excuse my English, when the shit hits the fan. That's the excrement or the fun, depending on what you're evaluating, and that's everything that can go wrong. And then you put barriers, mitigations. So having this in mind, according to the hopefully right and accurate charts that you are using, you will need to be about 100 kilograms lighter to operate in Performance 1 on your brand new twin engine any day above 33 degrees. Make a risk-based, so probability, severity decision considering engine failures and other known threats. We heard today about performance. 33 degrees, that never happens here. We're in Cologne. Oh, come on. Don't worry about it. Well, check if you can do single pilot operation, or maybe use a HEMS crew member, or maybe reduce oil and gas passengers, or maybe check if you can go without air conditioning. Check if you can reduce your continuous fuel, because maybe you know how long your flight will be. Or check how non-hostile is that non-congested environment where you will make a safe forced landing with reasonable expectations of not hurting anyone if your critical engine fails, and if possible, try to get an approval to fly in Performance 2 with exposure. That is not easy to understand for those of us who don't speak English as our mother tongue, first of all. And second, payload in oil and gas operation may mean one paying passenger. In a HEMS operation may mean a co-pilot, a nurse, a doctor, medical equipment, so on. My point here is we are very interested in seeing what comes out from the review of performance in HEMS operations. Question number 4. Fatigue, big topic. Fatigue risk management. Everybody's talking about it. Many interesting things to be done there. Very important for attention. So you are working for an EAS operator. Your maximum daily duty is, considering applicable exceptions, 12 hours, 14 hours, 15 hours, all of the above, and some more options depending on where you're working, which country. I don't even know anymore. I had a bad night, and my roster is not published yet. Well, luckily, there is an MPA now working on all these subjects. It will be very interesting to see what comes out. But wait, there's more. Never mind, I'm not a pilot. I'm just a technician or an engineer doing a critical task. Oh, what are you talking about? I'm a director working on the budget on a Saturday. We have to think about fatigue management for more people. Because safety culture is everywhere. Safety culture is in the way you dress, in the way you drive, how you go up and down the stairs. Everything you do relates to safety culture. Another one good tip for you, integration of different management systems. Occupational health and safety with aviation safety, environmental management, compliance monitoring. Let's please make sure that we all know what are the risks and have the same priorities. And of course, emergency. Try to be always prepared for the worst. And that's how you can get good results, like a good operations control center, which is focused on safety. Zero accidents as a goal that now people believe. A reporting culture where people can raise their hand and feel free to say, okay, this is not wrong or this is not right. CRM, it's one of the few acronyms that I've used today. It used to be Cockpit Resource Management. It then went to Crew Resource Management. It should be Company Resource Management. It should be everybody integrated into that. Everybody should be aware of leadership skills, teamwork, assertiveness, etc. And FOD, Foreign Object Damage, another acronym that I use today. Well, that's an example of company resource management. Volunteers, directors for all the departments just cleaning the parking in Alicante. leadership and teamwork are needed to improve safety culture. It's the only way you will do it. That's a phrase that is very often used in safety presentations. If you think safety is expensive, try an accident. It works, especially when you have an accident. But it has a negative connotation to it. It's sometimes much better to work on the positive. If we know that working on preventing accidents is also working on preventing incidents, delays, complaints, that if you have a safe operation, things run smooth, then you will see more clearly the benefits of investing in safety. But of course, we also know that absolute safety is only achieved if you stop flying, if you stop operations, and we don't want that. So then somebody came up with the invention of an acceptable level of safety. But what defines acceptable? Is it how much cash you have? Or should it be the other way around? Should it be that everybody in this society, regulators, manufacturers, operators, insurers, maintainers, should be working to make sure that that phrase is true? An acceptable level of safety must be profitable, and an acceptable one not. That is what will make anybody believe in safety. I'm not finished yet. Just give me 1 more minute. What I'm trying to explain is that the best thing we can do to improve safety is to improve the mindset of the people who are working in this industry. The software update that we need is here, not here. Some people think that changing that mindset is very difficult. So I just want to give you a small demonstration that is not that difficult. This is not my idea. This is an experiment that was done in Madrid in 2015. It's only 3 questions. Question number 1. Think about the 2 people most important in your lives. Francisco? Think about the 2 most important people in your life. Okay? Now think about what will you get them for Christmas. You have it in your mind? Now, what will you get them for Christmas if you knew that this was their last Christmas? Thank you for your attention.
Thank you very much. I think now we have a good thinking about, and it lets everybody to think a little bit more, because the presentation was very original presentation. So now you're ready to start your question to our colleagues over there. Feel free. I have some questions, but I will wait for you before, because what we saw today was very interesting. Yes, please. Go ahead. Tim, you first.
Eric, I was trying to work it out. Do you need to have done the ATPL theory exams to do the twin CPL in a single pilot rated aircraft, certified aircraft?
Can you say that again, please?
Do you need to have done the ATPL theory exams? Is that going to be a requirement to take advantage of the 2 CPLs in a single certified aircraft?
Definitely not in VFR. Anytime the second pilot will be added to the crew on a voluntary basis, it's not going to be the case either. Or at least that's the idea behind the ROFC and aircrew changes that we'll be introducing.
Right, okay. As for the MCC, does it have to be on the type? Does it have to be on a helicopter? Because at the moment, to do a fixed wing, a 737 MCC, is about 25% the cost of doing a rotary MCC. all you're learning is a skill on how to monitor and cooperate. So why do we need to do it on a helicopter where you could say there's almost a monopoly on the simulators?
Well, first of all, the rulemaking group sessions are not fully over on this. It would probably be a good thing to keep a bit of suspense here and let you wait for the NPA to be published. But if I remember well, what we're interested in is the competencies and the multi-crew cooperation competencies, and that would not be dependent on the helicopter type, and could actually work out well with having been through this training on an aeroplane simulator as well.
Another question, please?
Yes, I have not understood exactly for which type of operation EBT will be mandatory. For private pilot, for example.
So, well, I'm going to pass then the floor to Eric, but basically the idea, and this is reflected in the concept paper of 0599 published in February 2016, the whole EBT is going to be on voluntary basis. There's not going to be any mandatory EBT program, let's say. So, of course, and we have said this in the concept paper back 2 years ago almost, the agency will try to promote the implementation of evidence-based training and through some alleviation similar to what is already done in ATQP, line check, SAP, etc.
Next.
Yeah, this is on. Keith Yim from the Dutch authority, the Dutch CAA. Question for Bettina. You raised some interesting issues. Now, regarding AOC and possibly ATO holders, are you seeing an increase in competency-based selection for pilots? That's the first question. And the second very quick question is, what is your opinion on the relevance of competency-based selection of post holders, of nominated persons, as they're called these days, with the belief that it begins at the top? And we're seeing a lot of our experiences that we come across, a lot of nominated persons who a typical nominated person is a pilot who stayed in the company for a while and then has come up the system and becomes a nominated person with no proper assessment of his or her competencies. Now, I have to say that with a bit of reservation because I came up that route myself. I'm a career pilot, I've retired, but also, and retired into another job, so I have to qualify that statement a little bit. But it is a concern that we're seeing. I just wondered what your opinion would be on that.
Okay. Yeah, as I mentioned already, competency-based assessment, but also development is very important, and I would absolutely agree that we should find some ways to have pilots assessments based on competencies, not only on the technical and professional competencies, but also on the social and personal competency level. The point of the nominated persons, I'm not that agreeing with you at the moment, because I think there are already regulations in place where, for example, I, as a quality manager, have to assess in, I think, not every year, but in a regular time, the competencies of my accountable manager, for example, in the helicopter operation. The question is how we do that in practice, but at least we have some ideas how to continue in this area. So, but I agree that that is a problem, perhaps, that we have nominated persons which don't have the competencies that you should have at the end of the day, which is a problem, yeah.
Yes, please, next.
Hello, I'm Klaus. I'm a pilot from Austria, and I do have a question to the gentleman from Babcock. You claimed that the last 4 years, I think since the end of 2013, you had no accident anymore, and you claimed it's not a good luck thing. So do you think it was just the culture? The first question is, did you change anything else, like the processing of reports or any other kind of safety culture items? And if you think it's a cultural thing, how did you change the culture in the last 4 years?
It's a lot of things. It's, of course, improving procedures. It's, of course, technology, training. But the culture change comes from consistency and from having a whole new look at how the management team and everybody else communicates and transmits and walks the talk. Okay? Conventionally, sometimes you may have that a company where the safety department is talking about safety, but then operations, production, marketing, not so much. What we did to start with was to get involved all the directors from the different departments into delivering the same messages. And we got them to visit our bases and give a speech about the importance of safety and their last record of accidents and so on, so that they saw that it was a common thing. That to me was the tipping point where we got everybody involved, not just the safety or the concerned pilots.
Thanks.
Another question? No? No more question? I have a question personally regarding, Bettina, what you show on the screen, where you see the differences or the discrepancy between what the human factor is, what the human are capable with, and I will say the yellow curve, which seems to be a very exponential curve. Mm-hmm. So what will be the room of the human guy as soon as we will talk about artificial intelligence, for example? Where we will be there? What do you think about that? How can we react as a human guy? We are so poor facing what you show this morning. Mm-hmm.
Well, that starts another discussion, I guess. But at the end of the day, for me, it is an absolute mind shift, not only regarding the helicopter industry, but also every industry we talk about, to start thinking of or to make the limitations of the human being as starting point, and not to say, okay, we follow technology and everything that's technology driven possible, and to think about what makes sense and not to follow every technology drip or perspective and way. So I know that there's a lot of developments going on around artificial intelligence, and for me, if we continue on this way where technology drives business and not human beings and people drive business, we might get in the back, and we will. I don't know how to express this in English, but we might lose track and as human beings and might be overruled by technology, and artificial intelligence, which is a huge problem for mankind, you can say, at the end of the day. Yeah. So, and then probably not the right place to discuss, but that is at the end of the day, that's a problem for me, a huge problem.
Thank you. Another question, totally different, to Olivier and Carl. I just mentioned, you show the offshore operation over there and the PC2 DLA regarding the offshore helideck. What about the EMS operations? What about the elevated helipad? Can you recommend that, or do you have any differences?
Well, there's some obvious differences in the HEMS world that you don't have the ditching capability normally when you're in exposure time. Typically, you're over a city, over a hospital. But I think a lot of the ideas can be transmitted. I mean, we're talking really about exposure times in many cases, somewhere around 3 seconds, and you're talking about an accident. One accident in 250 million takeoffs and landings when you're at or between 250, I think it's when you're at a 3-second exposure time. If I think any CEO of a company would sign up for having only one accident in 250 million takeoff and landings, as we said, I mean, engine failures don't happen that often, and you know, we're taking a lot of other things into, we're taking a lot of disadvantages by using complex procedures, spending a lot more time in a risky environment where we take off vertically or rearwards, spend quite a bit of time there rather than just going through it in a few seconds. And so it's something to be weighed, and I think that in many cases the overall risk of having an engine or having an accident following an engine failure is probably smaller when you would use that approach, because you have a short exposure time. But a simple procedure is something that, you know, you do without thinking much about it. Whereas we all know if you have in some of the CAD procedures that exist, okay, if you do everything right, you're gonna end up safe. But if the pilot is just startled for just a little too long by what's happening, he may end up messing up just as much, you know, just as much the same whether he's in a PC1, PC2, or no PC performance category. So I think there's a lot of thought to be given to that, and it could really make a change in how we see safety in that respect.
Okay, thank you. And my last point is not a question; it's just a comment regarding Olivier. You mentioned the fact we could also improve the procedure by increasing the height of the TDP. I have some issue about that. I have personally some reserve on it, because you have to consider by day and by night the procedure itself. So as soon as you climb a bit too much, you don't see anymore, and you don't have any or sufficient reference. So you have to take into account this also, probably. Yeah?
You are perfectly right, but take into account that we have a good autopilot, and tomorrow we need to put more automatism in the procedure, because we think that the pilot is here to manage the situation, but perhaps the helicopter can help the pilot to do that.
Yes, good point. As soon as you talk about the better autopilot systems, we recommend, a number of people here will recommend you to have an automatic approach to the offshore, not only to the decision height, but to the rig and to the lead deck. So please go that way to help the people over there.
We are working on that presently.
Thank you very much. Other questions? Yes?
Hello, this is a question to more or less all of you, and you can select who should answer if possible. I will take the phrase of luck, which was used. So luck could be also a combination of being focused and then consequent. Now I have heard something about procedures. I would say something about culture, something about human factor, and something about training. Your recommendation, where should we focus most on?
Automation, are you sure?
Pardon?
I would go for training.
Yeah, training is perhaps a good starting point, yeah, because everything is related to training, but yeah, beyond the typical training that we actually have. So, yeah, other ways of doing training and conducting training.
I am the project manager of ROFC. Rulemaking task is about training. However, I want to say a note, and we have this in the data report very clear. Training cannot be all, and not all the operational risk can be mitigated through training. That's why we do the training criticality survey in the data report for helicopters and for airplanes, which we determine which operational risk can be mitigated. A lot of them can be mitigated through training, but this is not all. I don't know.
We did focus a lot on pilot training, but I think one of my fellow presenters also discussed the fact that safety was everybody's job, and there would be a lot more, sometimes training, sometimes safety culture to be disseminated throughout aircraft operators or throughout the industry, and not only to the pilots. That would complete my answer.
Yes, just to conclude, I think the best recipe in general is to mix the different ingredients and just to spray the good, I will say, the good rate of each of them. So it is not only one, it's probably an adequate mixing of things, probably.
Maybe I can put a wish for the next, let's say, EASA session to get an indication what would be the right mixture of all these things for the future.
Okay, thank you very much. So now it's time to get a coffee break. So we will come back in let's say, yes, 11:20, yes, 11:20 we come back all together for the next session.